Today I am going to discuss about in the distribution system, interconnected distribution system, AC distribution, voltage calculation. The last class we have discussed for radial distribution system and then ring distribution system. Radial distribution system is a open loop system. In radial distribution system used for light and then medium load applications, that is used for small towns and rural areas, etc. In radial distribution system, the major drawback is if any fault occur on the feeder, all the consumers are affected for the power cut. And one more drawback is the end of the consumers get affected serious voltage fluctuation due to the variation of load. In radial distribution system, is fed by only single distributor and the voltage drop is more. Radial distribution system is not reliable and not economical system. In ring distribution system, what are the drawback in the radial distribution system that overcome in the ring distribution system? That is, ring distribution system is a closed loop system and it consists of two or more distributor. The voltage drop is also less and each feeder is connected for the each distributor is connected for the two feeders. Suppose if any fault is occur means the parallelly without uninterrupting supply, they will be shared for the load sharing. This is the ring distribution system. In ring distribution system, the voltage drop is less. Maintenance and repair is also easy. Reliable when compared to the radial distribution system. And the voltage fluctuation is also less at the consumer end. And this is the interconnected distribution system. In radial and then ring main distribution system is connected for one or two substations. But in the interconnected system, n number of substations are connected and n number of distributors are there. In this, the schematic diagram, you can observe 4 substations are interconnected. This is nothing but the centrally. All the substations are connected to one system, that is interconnected system, that is represent for substation 1, substation 2, substation 3 and then substation 4, and the distributor is also distributor 1, distributor 2, distributor 3 and then distributor 4. Based upon the requirement, they can connect it for the n number of distributor. Here in interconnected distributed system, 2 or more than 2 generating stations or else the substation is connected in a single point and n number of distributors are there. It is also one type of closed loop system. Here, if any one of the substation is failure, unfortunately, you can take this is the substation 1. In this substation 1, they are sharing, for example, you can take either 132 kV and the second substation is also sharing for 132 kV and the third substation they are for example, you can take 220 kV and the fourth one you can take either 66 kV or else 400 kV substation. So all the substations is interlinked to one central, that is in this system. Here they are kept for the step down transformer. From this, the feeder they are kept for the separate the step down transformer. Here one more step down transformer. Separately for all the 4 feeders from the substation feeder, they are connected for the step down transformer. These the step down transformer, the step down into either 33 kV or else the 11 kV. 33 kV or else the 11 kV. Here 132 kV is step down into 11 kV or 132 kV and 220 kV is step down into 11 kV or 400 kV is step down into 11 kV or else the 66 kV is step down into 11 kV. After that, the distributed into n number of distributors. For example, you can take this is the closed loop system for our representation A, B, C, D, E, F, G and then H. The distributor represent for B, D, F and then the H. That is the receiving point, the connected the substation is represent for A, C, E and then G. A, C and then G. Again, here the distributor fed at B, D, F, and then H. Again, they are kept for the step down transformer. These the 11 kV. Again, the step down into 400 volt. The 11 kV is stepped down into 440 volt, 3-phase, 3-wire or 4-wire system, or else 230 volt, the single phase system. Here connected for the n number of consumers. Connected for the n number of consumers. Here the advantages is it increases the service stability. For example, you can take, suppose on a particular day, the substation is considered for the any problem, that is here already we are receiving for 132 kV. Unfortunately, for example, in terms of load, you can take, for example, that is 50 kilowatt. In this substation, they are received for example, 50 kilowatt. Here they are received, for example, you can take 130 kilowatt. From this, the substation 4 they are receiving from 200 kilowatt. Here, from all the substations they are receiving and shared in the central. The load shared in the center. Unfortunately, the substation 1, the fault failure is occurred. They need to rectify the fault. It takes 1 hour time duration. Now at that time, the 50 kilowatt is shortage. Now what happened? The remaining the 3 substations, the sharing this 50 kilowatt load. 50 kilowatt. Here they are interrupted. Here they are disconnected. It is in a closed loop system. Now here they are feeding from this. The substation 4 is sharing the load to, in this, the distributor B and then distributor H. Now here the load is shortage means that the shortage load is sharing from the substation 3. Substation 3. That is, it increases the service stability. And similarly, suppose the substation is failure means they can share the load. At the same time, unfortunately, here the fault is occurred. Here the fault is occurred. They are interrupted in this the particular point. This the substation load is shared for, in this the distributor. Again the load it will be shared. They are taken from this in this connection. They are taken in this. Here the load is supplied from the substation 4, substation 3, substation 2, and then substation 4. Like that the load it will be sharing. They can share for the uninterrupted power supply. And one more advantage is efficiency is more comparing to the radial and then ring distribution system. In interconnected distribution system, it improves the efficiency. And another advantage is if any one of the generating station during peak load hour cannot flow from the another generating station. Suppose here the load is, generally it is shared in this, the distributor is, the load is sharing from substation 4 and then substation 1. Unfortunately, the substation 1 is load sharing in this distributor also. Unfortunately, if the load is not satisfied in this the 2 distributor, the load can be shared. This is substation 2 or substation 3. Like that, the load it will be shared for all the distributors, because all the substation is connected for central and the load is also sharing from the central. Comparing to the radial and then ring distribution system, the more advantages in the interconnected distribution. In radial distribution system, only single distributor are there, but in ring distribution system, n number of distributor, only few connected, few substations. But interconnected distribution system, n number of substations are connected in a single point and n number of distributor from a single point. These are the major advantages of the interconnected distribution system. And next topic is AC distributor. At present, the maximum we are depending for the AC supply comparing to the DC. That is, in a world maximum, 99% of the power supply we are depending only for the AC system. That is, for distribution system we are used for, that is the 11 kV. That is primary distribution system. Another one is for the secondary distribution system. The primary distribution system, the operating voltage is 11 kV. And the secondary distribution system, the operating voltage is 440 volt 3-phase supply, or else it is represented for 230 volt the single phase system. 230 volt single phase system. This represent for the primary distribution system 11 kV, and this is for the secondary distribution system, that is 440 volt for 3-phase system, 230 volt for single phase system. Again, it is represent for HT line and then LT line. HT is represent for the high tension, that is operating voltage is more, and LT is represent for the low tension, operating voltage is less. That is the primary distribution system. This is represent for the HT line, that is high tension line, and the secondary distribution system is represent for the low tension line, that is operating voltage is low, that is 440 volt or 400 volt for three phase system, and then 230 volt for single phase system. Here we can find out how we can find out for the voltage drop calculation, and the voltage drop calculation is similar for the AC as well as for the DC distribution system. The voltage drop calculation is similar for the AC as well as for the DC distribution system, but the major difference is in AC distribution system, the parameters are resistance, inductance, another one is for the capacitance. But in the DC distribution system, the parameters only available for the resistance. Inductance and capacitance are eliminated or neglected. Due to that, the losses is also less. In AC distribution system, the parameters are three parameters: resistance, inductance, another one is for the capacitance. But in the DC distribution system, so only the parameter is available for resistance. Now, in AC distribution system, the voltage drop is due to the effect of resistance. In DC distribution system, the voltage drop due to the resistance alone. But in AC system, the voltage drop is affected for the combination of resistance, inductance, as well as for the capacitance. And one more thing, in the DC distribution system, the voltage drop is less and the efficiency is more, because due to the inductance and capacitance, lot of problem is taken place. That is Ferranti effect, proximity effect, spirality effect, skin effect. And one more drawback is in the AC system, if the operating voltage is increased, means more number of conductors are required. More number of conductors are required. Due to that, the voltage drop is more. But in DC system, the only the conductor is required for one or two conductors. In a single conductor also we can transfer the electricity. The ground, it is act as a return conductor. That is, in voltage drop, the major difference of the AC distribution as well as for DC distribution. In DC distribution, the voltage drop is affected only for the resistance alone. But in the AC system, the voltage drop is affected due to the combination of resistance, inductance, another one is for the capacitance. In DC system, we can calculate the current with the help of addition and then subtraction. But in the AC system, we can identify the current with the help of vectorial or phasor representation. That is the vector diagram or a phasor diagram. But in the DC system, with the help of adding and then subtraction. And comparing to the DC system, the AC system is good, because the major differences is impedances, current and voltage can be represented in terms of vectorial representation or else the phasor diagram. That is, here the reference you can take for the voltage or current. In DC distribution system, the current can be calculated simply, but in the AC system, we can find out the current with the help of impedances, that is represent for Z equal to R plus J XL. Z equal to R plus J XL. That is, the drop is resistance drop as well as for the inductive reactance drop. And this can be found out with the help of vectorial representation, that is nothing but the vector diagram or phasor diagram. We need to draw the vector diagram or phasor diagram. The take references is called as voltage or current. The voltage or current. And the last one is at load, the phase angle between voltage and current, it is taken from the two things. One is by taking supply voltage as the reference phasor. The another one by taking voltage at load point itself. There are two methods. We are taking the references. One is for the supply voltage as reference phasor. Another method is called as the load point itself is taken as the reference phasor. These are the how we can calculate the voltage drop calculation in the AC distribution system. It is more or less similar to the DC distribution system, but in DC distribution system, it is the voltage drop affected only for the resistance, but in AC distribution system, The effect is presented due to the combination of resistance, inductance, as well as for the capacitance. But in DC system, the operation used for addition and subtraction, but in AC system they are used for the vectorial method. In DC system, compared to the AC system, the identification of the current or calculation of the current is good, because here they are used for the impedances, voltage and current with the help of vectorial method, that is phasor diagram or vector diagram. Phasor diagram or vector diagram. But here the reference are taken for the voltage or current. That is how they are taken, means one is taken from the supply voltage as the reference phasor, another one they are taken from the load point itself taken as a reference phasor. That is AC distribution voltage calculation. Now here they are taken for the radial distributor, that is fed at one end and distributed only for the single point. This is open loop system. Here the distributor is fed at the point A, that is voltage A. Distributor at 2 points. The AC is the distributor fed at point A, and the distributor is at point B and distributor is point C. Now here the total current is flowing. For example, you can take here they are supplied for the 200 ampere. That is the fed at a voltage. The voltage is common throughout the line, the starting point to ending point. For example, you can take the 230 volt, the single phase, 230 volt, single phase, 58, and the load is 200 ampere. The load is 200 ampere. The two distributor is there, is connected in the series. Here the some amount of the voltage is dropped. Here the remaining voltage is flowing. Here I1 plus I2, the total current is 200 amps. The total current is 200 amps. Here the some amount of the current is dropped. For example, you can take here 120 ampere is dropped. That is I1 is 120 amps at an angle power factor. It is either 0.98 or 0.97, 0.9. What about the remaining current I2? That is I2 equal to minus I1. Total I1 is 120. What about the remaining current? 80 amps. That is I2 is 80 amps and cos phi 2. Similarly, the power factor is 0.98 or 0.98 or 0.97. This is for the theoretical, but for practical 0.92 to 0.99. But theoretically, they are considered as a 0.7 power factor or 0.8 or 8 to up to unity power factor. Here the impedance is there. In between the AB, the impedance is there. That is the impedance Z equal to R plus JXL. JX. That is R is nothing but the resistance. X is represent for the inductive reactance. Here they are considered for the limit 1. That is A to B is current I. That is R1 plus JX1, R2 plus JX2. Total line length we don't know. That is either 100 kilometer or 200 kilometer or 150 kilometer. The total line length is L kilometer. Now up to the distributor AB represent for the L1 and BC is represent for L2. Now the AB distributor, it should be in the midpoint or either 40% or 60% or 70%. It is not accurate in the midpoint. Some of the distributor line in the midpoint, some of the distributor is connected for the 20% or 30 or 60 or 80%. Now here the considered the ABC, that is the point A, B, the C having the load current I1 and then I2. The load current is represent for I1 and I2, and the power factor is represent for cos pi 1 and then cos pi 2. Here R1 plus JX1 is the impedance of this the particular section AB, and R2 plus JX2 is the impedance of the particular section BC. Now here the current flowing in the section the BC. What is the current is flowing in the section? That is I2. And what about the current flowing in the section AB? I1 plus I2. Now here the current flowing in the section BC is I2. What about the voltage drop in the section? The voltage drop in the section BC is I2 into impedance, that is represent for Z2. This is Z1 is equal to R1 plus JX1 and Z2 equal to R2 plus JX2. That is I2 into Z2. That is voltage drop in the section BC. Now that is I2 equal to, what is the value of Z2? R2 plus JX2. Now here we want to find out what is the voltage of VB and what is the voltage at the VA. Now we can find out how much the voltage drop. Here the VA, for example, you can take VA, we are sending from 240 volt. We can find out VB means how much the voltage drop in between the section AB. Now the VB is, for example, you can take 228 volt. And what about the VC? That is 220 volt. Like that we can find out the voltage drop in the section AB, voltage drop in the section VC. Now we can find out what is the voltage at point VB and what is the voltage at point VA. Now that is, consider the AB distributor ABC. What is the load current of the section point B distributor I1 and I2, that is the distributor C, that is B and then C of the power factor is represented for cos pi 1 and then cos pi 2. And R1 plus JX1 is called as the impedance of the section AB, and R2 plus JX2 is the impedance of the section BC. And from this, the diagram, what is the current flow in the section BC? That is I2. That is the current flow in the section BC is I2. What is the current flow in the section AB? That is I1 plus I2. And voltage drop in the section is the drop, that is I2 into Z2. We are represented this, the drop, the impedance is Z1, that is R1 plus JX1. This represents the impedance Z2, that is R2 plus J into X2. That is voltage drop in the section BC, that is I2 into Z2. What is the impedance Z2? R2 plus J into X2. That is BC equal to I2 into R2 plus J X2. Here we want to find out voltage at the point B. That is voltage at the point B equal to voltage at point C plus the drop in the section BC. This is the condition. Here we want to find out what is the voltage at the particular point B, that is VB equal to voltage at point C BC plus the drop in the section BC, that is VB equal to VC plus what is the drop in the section BC? I2 into Z2, that is I2 into Z2. That is VB equal to BC plus I2 into Z2. That is I2 into Z2 in the sense I2 into R2 plus J into X2. Now we have find out the voltage at the point B. Similarly, you can find out voltage at the point A. What happened? That is voltage at the point VA equal to what is the voltage at B? That is VB plus the drop in the section AB. What is the drop in the section AB? The current in the section AB into impedance. The current in the section AB into impedance. What is the current in the section AB? I1 plus I2. That is the current in the section AB. And what is the drop in the section AB? That is I1 plus I2 into impedance Z1. That is I1 plus I2. That is current in the section AB. And the impedance Z1 is R1 plus J into X1. This current in the section AB, I1 plus I2. Voltage at point A equal to voltage at B plus the drop in the section AB. What is the VA equal to voltage at point VB? What is the drop in the section AB? I1 plus I2 into impedance Z1. That is I1 plus I2 into R1 plus J X1. Like that we can find out for the AC voltage calculation, that is AC distribution voltage calculation. Here in this section they are taken for the radial distribution system. In radial distribution system, that is fed at one end and the connected in the single feeder, they are connected for the distributor. Here the major drawback is if any one distributor, the problem is taken place, the connected all the distributor are affected for the power cut. Here, that is the supply is fed at A, the distributor is point B and then point C. The total current is I1 plus I2. Here the distributor, some amount of current is dropped, that is taken for the I1 and then cos pi 1. Here the remaining the current is dropped, the remaining total current I2 and then cos pi 2. And in between the section AB, the impedance is represent for Z1. In between the section BC, the impedance is represent for Z2. Now here we want to find out what is the voltage at the point VB, what is the voltage at the point VA, that is VA, VB and then VC. Here we are find out how much the voltage is dropped. We are calculating AC voltage drop calculation. For example, you can take, they are supplying the VA equal to 240 volts. How much the drop in between AB? That is, we can find out the VB means we can find out in between how much drop. For example, you can take here 230 volt VB. Now, what about the VC? That is 220 volts. In this section AB, the drop is 8 volt. In section BC, the drop is 12 volts. The total the drop is 20 volt. In between the AB, the voltage drop is 8 volt. In between the VC, the voltage drop is 12 volt. This is not practical. I am telling the example. Now we want to find out the voltage at B means voltage at point C plus the drop in the section AB. Now we want to find out the drop in the section means what is the current and product of the impedance. Here, what is the current in the section BC? I2. The impedance in the section BC is Z2. That is, the drop is I2 into Z2. Similarly, we can find out voltage at A equal to voltage at point B plus the drop in the section AB. What is the drop in the section? The current with respect to the impedance. The current is I1 plus I2 and the impedance is Z1. That is R1 plus JX1. Now we can draw the phasor diagram or vector diagram. That is, we need to take the reference is current or voltage. Here, how many voltages are there? 3 voltages. One is for the VA, VB, the another voltage is for the VC. How many currents are there? 2 currents. The reference you can take for the load current. That is the reference we are taken for the load current I2 and one more current is I1. That is the current we are taken for the reference. And the vectorial representation is in between I1 and then I2. That is I1 plus I2. And 3 voltages are there. VA, VB, VC. The sending end voltage is maximum and receiving end voltage is the minimum. That is, the higher value is for VA and then VB. The next one is for the VC. Now, that is, this is represent for VC, VB and then VA. The higher value is for the VA. Now, there is 2 drop is there. One is for the resistance drop, another one is for the reactance drop. In between VC to VB, what is the drop? I2 into R2, I2 into X2. The resistance drop is parallel and the reactance drop is perpendicular. That is I2 into R2 and the reactance drop is perpendicular. That is I2 into X2. And in between AB, that is I1 plus I2 into R1, I1 plus I2 into R1. This is resistance drop. The reactance drop is perpendicular. That is I1 plus I2 into X1. I1 plus I2 into X1. Like that we can draw for the phasor diagram or vector diagram. But here there are 2 conditions there. One is for this taking supply voltage as the reference phasor or the voltage at the load point itself. Now we can observe what is the difference of the voltage as reference phasor and then load point itself. Now this is the phasor diagram or vector diagram. Here the 2 cases they are considered. One is for the vector diagram with respect to the receiving end. That is, the 3 voltages are there: VA, VB, VC. The higher value is for VB, medium, and then the lower value. That is, the drop is I2 into R2, I2 X2, and here in between AB, the drop is I1 plus I2 into R1, I1 plus I2 into X1. The current we are taken for The reference is the load current I2, I1. Now that is respect to the receiving end means that is VC with respect to the I1. The receiving end means that is the load end side. Load end side. That is the load end voltage is VC with respect to the I1. That is represent for the phi 1. And the load end VC with respect to the I2. That is represent for the phi 2. But in the load point means that is taken for the midpoint. Load point means taken for the midpoint. What is the midpoint? The B distributor B. That is VB to I1, that is represent for the pi 1, and VC to I2, that is represent for the pi 2. This represent for the pi 2. In this section, we are discussed about radial distribution system, ring distribution system, and then interconnected distribution system. Out of radial, ring, and then interconnected distribution system, they are taken from the ring distribution system or interconnected distribution system. If the distributor, n number of distributor are connected means they will be go for the interconnected. That is the connected, the substation or generating station is minimum means they will be go for the ring distribution system. And we have discussed for AC distribution network, that is how we can calculate the voltage drop. That is what is the major difference between the calculation of AC distribution as well as for the DC distribution voltage drop calculation. And we have seen for the one practical example of the AC distribution voltage calculation, the example taken for the radial distribution system.